Hello everyone, myself Dr. M.S.J. Smitha, Associate Professor of AAA Department in Anantalakshmi Institute of Technology and Sciences. Today let us study the topic armature reaction. By the end of this session, you will be able to know what is armature reaction and what is the magnetic neutral axis, geometrical neutral axis, and what are the effects of armature reaction. Okay, let us start the session. Armature reaction. The armature reaction is the impact of armature flux on the main field flux. Okay, armature reaction simply shows the effect of armature field on the main field. What is this armature field? Armature field is the field which is produced by the armature conductors when the current flows through them. Okay, and what is the main field? It is produced by the magnetic poles. This armature flux causes two effects on the main field flux. The first effect is the armature reaction distorts the main field flux. The second effect is it reduces the magnitude of the main field flux. Let us study this armature reaction considering a two-pole DC generator. See here, this is the two-pole DC generator, North Pole and the South Pole, and these are the magnetic lines of force before the armature reaction. Okay, let us study this armature reaction considering three cases. The case one is when no load is connected to the generator. When no load is connected to the generator, the armature current becomes zero. Okay, in this condition, only the MMF of main poles exist in the generator. The MMF flux is uniformly distributed along the magnetic axis. See here, this is the magnetic axis. Along the magnetic axis, the flux is uniformly distributed. Okay. Let us know what is this magnetic neutral axis. Magnetic neutral axis is the axis through which no EMF induces in the armature conductor. Okay, no EMF will be induced in the armature conductor. Such type of axis is known as magnetic neutral axis. The brushes and the commutator are placed in the magnetic neutral axis. Coming to the geometrical neutral axis. Geometrical neutral axis is perpendicular to the stator field axis. In this case, both the magnetic neutral axis and the geometrical neutral axis will be coinciding. Okay. And the distribution of flux is uniform along the magnetic axis. This magnetic, as I have told you, the brushes and the commutators are placed in the magnetic neutral axis. This axis is also called as axis of commutation. Okay. Then coming to the second case. Second case is when armature conductors are carrying the current. When armature conductors are carrying the current. That is, we'll be considering only current through the armature conductors and there will not be any current flowing through the main poles. Okay. The direction of current remains the same in all the conductors lying under one pole. See here, if you observe this is the conductors lying under the North Pole and these are the conductors lying in the South Pole. Okay, if you observe the direction of current flow, okay, under the North Pole, how it is, the direction of current is, let us know how this direction of current is given. The direction of current which is induced in the conductor is given by the Fleming's right hand rule. Okay. Direction of current is given by Fleming's right hand rule. What is Fleming's right hand rule? When the forefinger, thumb and middle finger are placed at 90 degrees with each other, okay, the thumb indicates the direction of motion of the conductor, okay, the forefinger indicates the direction of magnetic field, and the direction of current is given by middle finger. Okay, this is the direction of the thumb which shows the motion of the conductor, direction of the forefinger which gives the direction of magnetic field, and the middle finger represents the direction of current. Okay, under the north pole, if you observe the direction of current, it is going into the paper. Okay, the direction of current will be into the paper, whereas in case of south pole, it is going out of the paper. It is represented by the dotted lines here. It is represented by the cross lines. Okay. Due to this, see how the flux, magnetic flux is distributed when the current is flowing through the armature conductors. Okay. These lines represent the direction of, this arrow represents the direction of distribution of flux when the current is flowing through the armature conductors. Okay, direction of flux will be downwards due to the armature flux. When current is flowing through the armature conductors, distribution of flux will be in the downward direction. The flux direction is given by the corkscrew rule. Okay, what is this corkscrew rule? When we try to fix the screw, okay, we'll be rotating it from left to right. Okay, from left to right. The direction of flux is given by the corkscrew rule. Consider this as the conductor. Okay, when we try to move the screw from left to right, okay, that is how the flux distribution, direction of flux distribution will be given. Okay. Hope you understood this second case. Second case is what? Direction when the current is passed through the armature conductors. Okay. Then coming to the third case, that is considering both armature current and the field current. Okay. Both are acting simultaneously on the conductor. Armature, the machine has both the fluxes, armature flux and the field pole flux. The armature flux is produced by the current induced in the armature conductors, while the field pole flux is induced because of the main field poles. These two fluxes combines and gives the resultant flux phi r. Okay, this is the direction of the resultant flux. Original flux neutral plane was coinciding with the geometrical neutral axis. Okay, whereas resultant flux neutral plane is this shown by this line. Okay, this is due to the armature reaction. That is when both the armature flux and the main field flux coincides and the neutral axis is shifted here. See here how the flux distribution is. Consider this as the upper tip and this as the lower tip of North Pole, upper tip of South Pole and the lower tip of South Pole. when both uh, armature flux and main field flux are coinciding, this will be the flux distribution. Okay, it is high at the upper tip of south pole, low at the lower tip of south pole, whereas in case of south pole it is higher at the lower tip and lower at the upper tip. Okay, this shows the density of flux distribution. Okay, the resultant flux induces in the generator are shifted towards the direction of the rotation of the generator, and the magnetic neutral axis is always perpendicular to the axis of the resultant flux. This will be perpendicular to the axis of the resultant flux. This magnetic neutral axis is continuously shifted with the resultant flux. As the resultant flux keep on changing, this magnetic neutral axis is also shifted according to it. Okay, this is what is armature reaction is. The effects of armature reaction are: armature reaction reduces the total flux. This is known as demagnetizing effect. And the resultant flux is distorted. Okay, there is some distortion in the resultant flux due to which the magnetic neutral axis is shifted. This is in case of a generator. The direction of magnetic neutral axis is shifted with the direction of the resultant flux. Okay, this will be opposite in case of motor. Okay, the armature reaction induces flux in the neutral zone. This is the other effect of the armature reaction, that is, armature reaction induces the flux in the neutral zone, and this flux generates the voltage that causes the commutation problem. These are the effects of armature reaction. The three effects are: armature reaction reduces the total flux, okay, and the resultant flux is distorted. The second effect, due to which the magnetic neutral axis will be shifted. The third effect is the armature reaction induces the flux in the neutral zone. This flux generates the voltage that causes the commutation problem. These are the effects of armature reaction. Thank you for your patient listening.